This week, we will be doing electrogravimetry to determine the concentration of an unknown copper sulfate solution. The word electrogravimetry can be broken down into two parts, which, when thought about, can be considered a literal definition of what we will be doing this week. The first part of the word is electro, which could mean several things. Here we'll think of it as being related to electrons or electricity. The second part of this word, gravimetry, should be ringing bells from earlier this semester when we did Experiment 2, in which we used gravimetric analysis to determine the percent of chloride in an unknown sample. If you remember, you did a lot of weighing in that experiment. So that was a long way to get to the point, but gravimetry is a way of saying to obtain the mass of. Putting the two parts of the word together, you get a technique in which electricity is used to determine the mass of an unknown. A more exact definition is written in the blue box. To determine the concentration of the unknown copper sulfate solution, we will be making a crude electrochemical cell that will partially resemble the cell on this slide. In the cell, you can see an aqueous solution, which in our case will be a diluted copper sulfate solution. Concentrated acid is added to the copper sulfate to make the copper ions more accessible. Sodium sulfate is also added to maintain the charge balance as the electrochemical reaction is exhausted. The anode, which is a positively charged electrode, is made of carbon graphite. Once a current is supplied by the battery pack, electrons in solution move to the anode, through the wire, and to the cathode, which in our case is the brass hook. As a consequence of the movement of electrons, the graphite is oxidized, causing it to fall apart over time. This will be noticeable by shards of graphite at the bottom of the beaker. Another consequence of the electron movement is noticeable at the cathode, where the brass hook is attached. Reduction of the copper 2+ ions in solution leads to the solid copper forming onto the brass hook. By weighing the brass hook electrode before and after the electrochemical reaction, we can quantify how much copper is in the solution, which should allow us to determine the concentration of copper sulfate in the initial solution. The first important calculation is to determine the mass percent of copper deposited onto the brass hook. This is done by using the equation percent copper equals A divided by B times 100%. Where A is the mass of copper precipitated onto the brass hook, and B is the mass of the brass hook after the electrochemical reaction. Now, to determine the concentration of the unknown solution, we must convert the amount of copper to copper 2 sulfate pentahydrate. To make a copper solution, it is often bought as a hydrate, meaning water is included to make it look crystalline. If you would like to see what anhydrous versus hydrated copper sulfate looks like, ask one of your TAs. We'll show you. But to convert from copper to copper 2 sulfate pentahydrate, we will use dimensional analysis. To start, multiply the grams of copper deposited on the brass hook by the molar mass of copper found in the periodic table. Knowing the chemical formula of copper sulfate, we know that there is 1 mole of copper and 1 mole of copper sulfate pentahydrate. Doing this math will tell you the moles of copper sulfate pentahydrate, and if you want, you can determine the grams from here. Make sure you include the waters in the molar mass, though. Now all you have to do is divide by the volume. Make sure you think about if you need to account for dilution or not. From here, you should be able to calculate the copper sulfate pentahydrate concentration in parts per million. Here's the first part of the procedure. It may look a little complicated at first, but I promise it's not as difficult as it looks. Pause here and make sure you write down the method for cleaning the brass hooks. Here's the second part of the procedure detailing cleaning of the graphite electrodes. The picture to the right is what the electrode looks like. Here's the third part of the procedure detailing how to make the diluted copper sulfate solution for your electrochemical cell. Please stop here and write this in your notebook. Here's the most challenging part of the procedure. Please refer to the picture here as well as the one on the first slide to see what the setup should look like. If you have any questions, make sure you ask one of your TAs. Pause here and write this down as well. This is the last part of the procedure. This part should be done the day after you have lab. The picture is what your brass hooks should look like if the experiment is done properly. Please pause here and write this in your notebook. Experiment 7 will be graded as a full lab report. Here's an idea of what we'll be looking for.